Okay, calculus, further applications of derivatives. Remember arc length? Well, now there's parametric arc length. If x is a function of t and y is a function of t over the interval a, b, the parametric arc length is the integral from a to b of the derivative of x with respect to t squared plus the derivative of y with respect to t squared and the square root of that sum, which looks similar to our arc length formula before. So an epicycloid is traced by a point on a circle of radius 1 rolling around a circle of radius 4. This picture is more clearly defined in your online notes, but its coordinates are defined by x equals 5 cosine t minus cosine 5t, and y is 5 sine t minus sine 5t. Find the distance. Traveled in a whole revolution, 2 pi. Okay, it makes 4 little clover leaves, so we're just going to go from 0 to 2 pi, or I mean pi over 2, and multiply by 4. It's the same thing 4 times. So x prime, the derivative with respect to t, would be negative 5 sine t plus 5 sine 5t. Y prime is 5 cosine t minus 5 cosine 5t. Okay, so it says I need to square both of those things, which is kind of unfortunate for everyone, but let's do this. Okay, so x prime squared is, we're going to have 25 sine squared t minus 50 sine t sine 5t plus 25 sine squared 5t. Y prime squared is going to be similar. That would be 25 cosine squared t minus 50 cosine t cosine 5t plus 25 cosine squared 5t. Put in frame. Okay, those two things get added under a square root. So we have the square root from 4 times the square root from 0 to pi over 2 of all those things added together. Now let's talk about 25 sine squared t plus 25 cosine squared t, 25 sine squared t 5t plus 25 cosine squared 5t. Those will just become 25s each, so this should be the square root of 50. Now, the problem is we've got this other stuff going on. We still have a minus 50 sine t sine 5t, and also minus 50 cosine t cosine 5t. Probably wondering, what in the world are we going to do with that? Well, I think there are some trig formulas that are product of sum. So let's think about that. If you've got 50 sine t and 50 sine 5t, then let's look at what we can do here. I believe this will end up dealing with one of our trig conversion formulas. Okay, so something interesting that happens is, so if you take the cosine of 4t, that is the cosine of 5t minus t, and it breaks down into cosine 5t, cosine t, minus sine 5t, sine t. So this entire thing gets turned into, this is now 50 minus 50 cosine of 4t. Now, I wouldn't focus too much on that. Why? Because, here, we'll make a little aside here. Let's find something to write on. Okay. So as a little aside, I'm interjecting something. Let's talk about what we're going to do with this. So right now we have 4 times the integral from 0 to pi over 2 of the square root of 50 minus 50 cosine of 4t by that last conversion. This requires your cosine of a minus b. Don't worry so much about that. So if I factor the 50 out, so 50 times 1 minus the cosine of 4t. So, do you remember that power reduction formula? Sine squared theta equals 1 minus cosine theta over 2, which means 2 sine squared theta equals 1 minus cosine theta. But in our case, a theta is this is 1 minus cosine 2 theta. I was like, what's going on here? We need this to be 4t, so 2 theta equals 4t, which means theta equals 2t. So this is really 2 sine squared 2t equals 1 minus cosine 4t. So this whole thing turns into 50 times 2 sine squared 2t, which is good for us because this is the square root of 100 sine squared 2t, which is a perfect square root, which is 4 times the integral from 0 to pi over 2 of 10 sine of 2t. We can finally integrate. So this is 40. It's the integral from 0 to pi over 2 of sine of 2t. The integral of that should be 40 times, should be negative 1/2 cosine 2t, evaluated from 0 to pi over 2. Okay, so we know what happens when we plug in. So this is negative 20 times cosine of 2 times pi over 2 is pi, so it'd be negative 1. Cosine of 0 is 1. Negative 1 minus 1, so negative 20 times negative 2, which is 40. So the whole thing traveled exactly 40 units. That was a little bit of a scary problem. So I apologize for that, but it is what it is. Now, if we can do arc length, that means we can do area of a surface of revolution. Let's do an easier problem. C is a circle, x squared plus y squared equals 9, traveling just a little the beginning, from 3, 0 to 3 halves, 3 root 3 over 2. So, and we know it says solution step 1 is x equals 3 cosine t, y equals 3 sine t, from 0 to pi over 3. This we can work with. Now it says if we're rotating about the x-axis, which we're going to do in this problem, we use our y function, g of t, times the arc length formula. So we go from 0 to pi over 3 of our y function is 3 sine t, times the square root, the arc length. So the arc length is the two derivatives squared. So the derivative of x is x prime, which is negative 3 sine t, y prime, 3 cosine t. If I square both of those, x prime squared, I get 9 sine squared t, and then 9 cosine squared t, which is helpful for us because 9 sine squared t plus 9 cosine squared t, sine squared plus cosine squared is 1, so this is just 9. Nice for us, because what's the square root of 9? 3. So this whole thing becomes the square, or the integral from 0 to pi over 3 of 9 sine t. That integral is just negative 9 cosine t, evaluated from 0 to pi over 3, which is negative 9 times 1/2 minus 1, which is 9/2. And that's it.